Okay, so fine. So what we have seen is we have seen a lambda expression. When we understand a functional interface now, the idea of functional interface is it is used to represent a function. Okay. See, the point here is from Java 8 we say functions are first class citizens of the language. Functions are now first class citizen of the language. Earlier what you could use was only expressions. Fine. Say when if I have a variable, right? In a variable I would have some object. Fine. I would have a variable for an object. I would have variable for values. Fine. It was only values for which you would have a variable. Okay. But now we can have variable referring to a function. Fine. If I have something which is of type a functional interface, it would represent a function. A functional interface means I can have a function for it. See, say example is I can write a method, fine. Maybe there is a method returns void, there is a method m1 and says I am taking a comparator as a parameter. I am using comparator as nothing but something which is a functional interface. Just think there is a functional interface. Okay, comparator of E as a parameter. Okay. Now, if this is the case, how do I invoke M1? I'll have M1 and what can I use here? I need to have a comparator and here I can write a lambda. I am writing a function as a parameter. This wasn't there earlier. You only could have values, right? Yes. But now you can have functions. You have a method M2, okay, whatever parameters, return type is comparator. So I'm just taking example as comparator, it's some functional interface return type. Fine? Okay. The method here says return what? What? A function. You have, from a method you return a function. You can take input as functions. Fine. You can assign somewhere a function. Fine. Someone has declared function comparator. Okay, I can assign to it a function. Functions are now first class citizens of the language. And that is what is meant here, right? Just like values and objects, now you have functions. You could assign objects, you could return objects, fine? You could take parameters for objects, and you can do the same with functions. The lambda expression is a function.
Now we can pass the whole function also.
Yes.
So distributed computing without.
But it should be whatever you think of with RMI. You should say that functional interface should say it extends from serializable. Yeah. Then it will be okay.
Because it has to be partially this possible.
Yes.
Okay, that's good. This is very useful in distributed computing.
Fine. Okay, 1 second.
So we'll have to say implement serializable when we are defining the comparator, or like the lambda expression.
Lambda. No. Your functional interface type. It's not only comparator, right? You're thinking of a function for RMA, right? So that would be your own function. So you have your own functional interface. Okay. And I'll give some example of a functional interface which we might have of our own, and somewhere an application where it can be applicable, right? So maybe let's take a banking application. So we might have a class account. Okay. Let's say we have the class for a bank account. In this, you have your account number, name, balance. Now, you might have a withdraw method which says that yes, there is something like a minimum balance to be maintained. So you might have a static variable for a minimum balance. But if that minimum balance, you can go below the minimum balance whenever you withdraw, right? But if you withdraw more than the minimum balance, certain penalty should be deducted. Now, one option is you have penalty. One case was penalty as a fixed value. But someone says, oh, penalty can be a function. Then penalty would be a function. Now, what function should it be? Maybe you have different schemes. Or this account is from a priority customer, I'll have a different scheme for him. This is from a different kind of a customer, I'll have a different scheme for calculating penalty. Penalty, one thing, is now a function. I have a function to calculate penalty. The function would require two inputs. What's the current balance and what is the minimum balance required? What's the balance which has gone below the minimum balance and what's the minimum balance which was required? And maybe based on the difference, it can calculate, or sometimes it might be going for a fixed one, whatever. But penalty is a function. Right? So my account has a variable for penalty, and it might have a set penalty, get penalty methods. What is penalty? A function. So penalty is so it has a penalty type, so penalty function. When you may just call it penalty or a penalty function, right? So the withdraw method looks like this. So if you say withdraw, maybe you are trying to withdraw an amount. Okay. Fine. So check if the balance is sufficient or not. If you can't be withdrawing more than the balance, that's okay. Fine. So that check might be there already. But then you would also check that if it has gone below the minimum balance. So I'll say, okay. So withdraw, right? You do a withdrawal. Fine. So balance minus equal to amount is done. But once we have done this, it goes below the, suppose it goes below the minimum balance, then I must have a penalty. So if the balance is less than the minimum balance, what will I do? From the balance, further deduct the penalty amount. You might further deduct the penalties. So you might have penalty calculation. So this will say balance minus equal to what? Penalty dot, maybe you have a method called compute. That's the abstract method of your functional interface. When you are calling a function, this has to be some function where you are passing parameter as the current balance, right? So whatever is the balance and what was the minimum balance required. Okay. So we want to use it something like this. Yeah. Here is what we would like to use. This is where we are invoking the method and using. Fine. Compute. But what will be the compute? How does it compute? It's in this object. It's according to whatever you have assigned here. Okay. Fine. From the point of view of this particular class where we have this penalty as a variable, fine. So it's a setting. So you might have a set method called set penalty. So I'm assuming there is a set penalty method where penalty is a parameter, right? Set penalty is a fine. And then let's look at how we invoke this. Fine, I'm going reverse. Okay. I've first shown where the compute method is going to be called. Fine. Now let's see the invocation of setting the penalty. Okay. I'm going completely reverse, and then I'll be writing. Last thing I'll do is writing the functional interface. Okay. Fine. I'm completely reversing the whole thing. Okay. So you would have someone invoking. I'm assuming the set penalty method in this. Okay. Fine. Set penalty parameter is penalty. So if someone has created an account object, right? Account AC1, and whatever way he has initialized, he is going to call AC1.setPenalty. This is what would be possible. And what does he pass? A function. What does he pass? A function. A function which takes two inputs, balance and minimum balance. Okay. Right, and computes. Fine. Maybe his computation involves several steps. So here is computation where he returns some value. What is the computed value? Fine. On a different, I pass a different function. You can have different functions for calculating penalty on different objects of account. Oh, but how does this work? What have we used here? What's the type for this set penalty parameter? What is the type? Penalty. I'm using a function. This is possible only if it is a functional interface. Okay. Let's see what that functional interface might look like. Now, let's look at the interface of Java 8. Okay, some features of that interface, changes in Java 8, right? Let's see that also. So we have the public interface penalty. Okay. You want to keep it serializable, you can say extend serializable. That won't add a method. Okay. Fine. And then we have public abstract method. So by default methods here are public and abstract. Return type long, method name compute. Two parameters, one long for the balance, another long for the minimum balance. Fine, that's your abstract method. But okay, interfaces from Java 8 can include static methods. They can have instance methods. Default. Yeah, default methods and static methods. Okay. So someone says, let's add a static method to this. Returns penalty, a method to give you a penalty object. Okay. And the method name could be saying fixed. Static method, right? Parameter is long, the penalty value, P, let's say. Okay. And what do we write in this static method? Return. Okay. Okay, now recollect, we can write a, so we are writing a lambda expression. What's a lambda expression? Fine, return a function and the computation. Oh, I have already specified that this particular function always returns a fixed value P. But one thing I must take care is checking if the balance is greater than minimum balance, then it shouldn't be done like that. It should be 0. Okay. So balance greater than minimum balance, greater than equal to even, right? And greater than or equal to minimum balance. In that case, 0. Otherwise, P. Yeah, that's it. We add a static method like this. So somewhere I want to put that function where fixed value, right? Fixed penalty should always be there. Set penalty, penalty dot fixed. What is the value you want? Fine. Your interface, function interface has factory methods for that interface. Static methods available in Java 8. Fine, someone could think of writing a default method where two penalties could be combined. Oh, you have got another penalty object. On this penalty object, let me combine, add and give the new penalty value. You can be combining penalty values. Fine. So you may involve method. Fine. You might have methods which involves objects of the functional interface. Fine. Doing something on this object itself, combining it with something else. Okay. Or there is already some penalty function, right? And then I would like to always compute whatever that penalty function returns plus a fixed value. Okay, this is always going to increment by so much, a incremental penalty. And the idea is that yes, we can have methods. So those would be going as default methods, not as static. Fine, this would be default. Okay, fine. The method might still be returning a penalty, another new penalty object. Okay, and this might be saying increment the function, right? So increment by so much. And what we do here is, when we say return, so on a particular, this is given a penalty object, fine. How do I increase the value by so much? Okay, fine, you can write that return, you'll have this dot compute plus P plus the amount, fine, this whatever is the amount, this dot compute, you'll have to use this dot compute but for that you must have the values. And minimum balance.
What? It's like ABC one.
Or it might be fixed.
Yeah. But the idea was that yes, you can have default methods. There are cases where functional interfaces have been combined to create new functional interfaces. Fine, we'll see those examples. Right. What we are trying to now move towards is we are trying to look at the most commonly used functional interfaces. There are lots of a functional interface is nothing but one function. It is just one function. Fine, it's which has input parameters. Now there are certain very commonly used method signatures. So for those commonly found method signatures, we have got a whole package which provides us with all such function interfaces. Fine. That's the one which is java.util.function package. Function interface. So now let's proceed to looking at the commonly found function interfaces.
One
Yeah.
question.
Yeah.
This default function can be overridden, right?
Default function can be overridden by the implementing class also. Static anyway is never overridden. It's always, it's not involved in inheritance at all. Fine. Okay. So let's try to look at, yeah.
Super
Yeah.
is actually a keyword, right?
Yeah.
So how are we referring I1 dot super dot something? Because
Yeah.
the moment we use the class name or the
Yeah. Even
object,
when we had the inner classes,
um,
we have the similar thing. We have class name dot this.
so keyword is also referred as like
Yeah.
indirect reference is like an object.
Yes. Super and this are basically objects. When we say this, it's our object, current object.
No, super we cannot refer to them as object. Otherwise, then there will be multiple copies every time you are trying to
No,
refer
no.
to it.
It's a current object.
It's a current object.
Like
So-
this.
So सिंबल टेबल में उसका क्रिएशन होगा फिर रेफरेंसिंग सुपर का जैसे दिस का होता है वैसे
सुपर का अलग से नहीं बनता है.
नहीं